Okay, this is the last video on solving systems of linear equations on substitution. Okay, example 5. Here we have our two equations, 3x minus y equals 6, and 6x minus 2y equals 8. For the substitution method, we want to get one of the variables by itself, and it's your choice. I would say let's get this top row, and let's solve for y, because it doesn't have a number in front of it. All the other variables have a coefficient in front of it other than a 1. This one has actually a negative 1 in front of it. Let's write down this top row over here and get y by itself. So the first thing we need to do is subtract 3x on both sides. So now bring down the y. Actually, it's not y, it's negative y. And you could write it as 6 minus 3x or negative 3x plus 6. It doesn't matter. And then divide by negative 1 to get rid of that negative sign in front of the variable. So that'll turn into a positive y. So we have y equals 3x minus 6. Okay, so we took the top row and we got y by itself. So now we're going to take the bottom row, the other row, and in place of the y, we're going to replace the y with 3x minus 6. So we're going to go over here and replace that y with 3x minus 6. Okay, so the 6x we brought that down, the minus sign, the 2, and it's 2 times y, but in place of y, we put 3x minus 6. Okay, now we have an equation with one variable. The variable appears twice, but it's only one variable. So now we could distribute this negative 2 all the way through the parentheses. To get rid of the parentheses, that's negative 6x plus 12. Don't forget, negative 2 times negative 6 is positive 12. Now what happens here with the x's? When you add like terms, they cancel. So we're just left with 12 equals 8. Now we could subtract 12 on both sides to get 0 on the left side. You don't have to do that. From this step here, we could see that 12 does not equal 8. And there's no more x. So what is our answer to this equation? Right, there's no answer. It's no solution. Because 12 does not equal 8. So we could write as no solution. You could use this symbol with kind of a 0 with a slash through it to mean no solution. No solution, what does that mean as far as graphically? Remember that we're trying to find out where the two lines intersect. Well, if there's no solution, that means that the lines do not intersect. If the lines do not intersect, it means they have to be parallel lines. So that's what we'll write here. No solution. The lines are parallel. And when the lines are parallel, we call that system an inconsistent system when there is no solution. Okay, so there's no solution. Basically, we have two separate lines. That should be what your teacher would want you to say. But there's no solution because the lines are parallel. That's it. All right, let's do one more problem. Okay, well, this one, we already have one of the equations with y by itself. So, looks like they did half the job for us. Cool. Okay, we'll write down the other equation then. And in place of the y, we're going to replace it with 3/2 x minus 3. Alright, so we have to distribute this negative 2 all the way through to get rid of the parentheses. Kind of doing that on the side over here. What's negative 2 times 3/2? Yeah, the 2's cancel. There's still a negative sign here, so it's negative 3x. Okay, so when we distribute this 2, it's going to end up with a negative 3x. Bring down the 3x. This negative 3x for this product, and then negative 2 times negative 3 is positive 6. Again, the x's drop out when you add like terms. Unlike the last example, we have the same number on both sides. 6 does equal 6. So what does that mean this time? Is it no solution? No, it is a solution because 6 does equal 6. It means that there's infinite solutions. If there's infinite solutions, what does that mean graphically? Right, it means that it's the same line. So these two lines are actually identical. If you were to take this top row and get y by itself, the answer would be this in the bottom row, the same equation. So we'll just simply write that here, that there's infinite solutions, and the lines are the same line. The equations are also called dependent when they are the same line. So this one's called dependent. And just a little note that the system is called consistent when there's the system is called a consistent system when there's at least one solution. This is also consistent because there is at least one solution. There's actually infinite solutions, so it's consistent. It's also dependent. Make sure you just know what your teacher wants you to write. There's infinite solutions. There is also a way of writing it in terms of a coordinate, but we won't do that here. We'll just leave it at infinite solutions. Sometimes they may want you to just write down one of these lines and say it's everything on that line. So all the points that lie on this line are solutions. Okay, that's it for this video. Kind of a short one. And we'll see you here for the next one.